Hello everyone. We are starting with the topic of electrical measuring instruments. This is the part 1 of the video series. We will look into some of the basics that we have to know to understand the rest of the material. So let's start with some basics. The first one that I have, the first point here is they are used to measure various electrical quantities. As you can understand from the term electrical measuring instruments, that they are used to measure various electrical quantities. Electrical quantities, mind that, like voltage, current, electrical power, electrical energy, power factor, and everything else. There are mainly two types of devices that are used. One is the analog type and the other is the digital type. Analog instruments, as you have already seen, like those instruments that have pointers in them that points to a particular location when a measurement is to be shown. Those types of instruments are analog instruments. And digital instruments, that you have seen a multimeter. Now, a multimeter directly shows the value of the quantity being measured. That is a type of digital instrument. Now, analog instruments work upon continuous signals. That means the signal is not broken at any part, and also they have the mechanical moving parts within them for working. As you have seen that there is a movable pointer in the analog instrument, so that it can point to a particular location, and digital instruments doesn't have those type of pointers, so there is no question of any mechanical moving parts there, and it works upon discrete signals. That is, the discrete signals are signals that we will get only at a certain interval of time, and after that interval we will not get any signal. For example, if we want a signal at 1 second, so we will get that signal at 1 second only, and we will not get the signal at any other. So for example, 2 seconds or 3 seconds, we will not get any signal for that. So those are discrete type of signals. So digital instruments work upon discrete signals. Next, this is a table which shows what type of meters are used to measure certain electrical parameters. For resistance, we use ohm meter. For current, we use ammeter. To measure voltage, we use voltmeter. To measure frequency, we use frequency meter. To measure flux, we use flux meter. To measure power factor, we use power factor meter. And also the meter that we use in the house to measure energy is the energy meter. That we generally call it as a simply as a meter, but it has the name. Particularly, it is known as energy meter. Now, some of the uses to determine the ratings of electrical appliances. As you have seen, in every electrical appliance, there is a label mentioning the maximum current the appliance can use, and the maximum voltage rating, so that beyond that voltage, it may get damaged. So there is a maximum voltage rating also. Those ratings are determined using the electrical measuring instruments. For laboratory purpose measurements, you already know that. For data recording in power generating stations and substations. Now, what in power generating stations, what power is being generated is to be recorded, to know that this amount of power is being generated right now. So for that recording purpose, it is used. Finding fault in a system, the fourth one. So as you have seen that when certain electrical if there is some electrical disturbances, we always see that the electricians always tell a thing, the like, we have to find the fault, what type of fault is being there in the system. So finding fault in the system is another use for the electrical appliances. We use the electrical measuring instruments to find what voltage or what current is being generated, and we compare that. We compare that voltage or current with the proper voltage or current that we may get from that system, and if there is the voltage or current rating is more or less than the signified voltage or current, then there will be a fault in the system. So finding fault in the system is another use. Now, there are some classifications of these types of instruments. So first of all, they are classified as absolute instruments and secondary instruments. Now, absolute instruments doesn't require help of any other instrument, and they give the output in terms of physical constant. For example, if a certain deflection occurs, a deflection means there is an angle change. So based on that angle, and every absolute instrument has a particular meter constant, so based on that meter constant and the angle deflection, they give the result. The examples of these types of instruments are Rayleigh's current balance and tangent galvanometer. The secondary instruments. These instruments are constructed with the help of absolute instruments. Now, for example, I have told you already about calibration. So, calibration means by comparing with a standard object, we construct a new object. So that type of instrument is secondary instrument. You already have Rayleigh's current balance or tangent galvanometer as the absolute instrument, and by comparing with them, we are building another device or another instrument. Those are termed as secondary instruments. So all types of instruments that we see generally are secondary instruments. Now, other type of classification include deflection type instruments and null type instruments. Now, what are deflection type instruments and null type instruments? See, you have seen the pointer type instruments there, that there is a moving pointer in the analog instruments. Now, in that case, there are two types also. First one is the deflection type, another is the null type. Now, what is the deflection type? Deflection type is that the pointer is already in the zero position, and when a certain quantity is being measured, it directly moves from the zero position to the position where the measurement is happening. That is, for example, you are measuring 10 volts. So from 0, the pointer deflects to 10. That is a deflection type instrument. In null type instrument, the case is something different. In deflection type instruments, we doesn't require any other quantity for reference, but in null type instrument we have to use a reference value. Now, comparing with that reference value, null instrument gives zero reading if the quantity being measured have the is of the same quantity with the known is of the same value with the known quantity. In null type of instrument, the it works on the property of balance. Actually, a known quantity has a certain value, and if the unknown quantity that is to be measured has the same value with that of the known quantity, then it will indicate a zero position. That means it will be balanced right then. So this is the property of null type instruments. Now, null type instruments are more accurate compared to deflecting time instruments, since it shows a zero position or balance position. It works upon the balance principle. So null type instruments are generally more accurate compared to the deflection type instruments. Now, another type of classification is that of indicating, integrating, and recording type instruments. Now, there are three types of instruments available. One is the indicating instruments that directly shows the value of the quantity being measured. For example, voltmeter, ammeter, or wattmeter, like you have seen. Another is integrating instrument, such as you have seen the household energy meter. It records the total energy being measured. Suppose it has to measure the total energy used for 30 days for 1 month. So for first day, some energy being used is measured. For second day, for second day, the total energy used for that day is measured and is added to the first day's energy. So in so this goes on integrating the total energy being used for 30 days. So that is the purpose of integrating instruments. So integrating instruments generally measures the total energy supplied at a particular interval of time. For example, energy meter. And the other is the recording instruments that records a certain condition at a certain interval of time. For example, ECG. As you have seen that for in a certain interval of time, ECG records the graph, the particular type of graph for that amount of time. So those are recording instruments. Thank you. That's all for now.